boys and girls. Today we are going to be looking at lesson 6.9. We're going to be looking for patterns with fractions. This lesson pretty much just helps you find patterns, use your critical thinking skills. Okay, so get ready with your book and your pencil to take notes. So here we are with lesson 6.9. We are on page 287. 287. Lesson 2.9, patterns with fractions. We're going to start off with writing the objective of our lesson. And remember, the reason why we do the objective is because this way you know what you will be learning, what to expect. So in this lesson, we will learn, we will identify, describe, and create numeric patterns with fractions. Okay, we will identify, describe, and create numeric patterns with fractions. So we're going to be looking at fractions again, but now we're looking for patterns. Very important skill to have in life. Look for patterns. So a pattern, what is a pattern? So we can say that a pattern is it's a repeated way of things happening. For example, when you were younger, in other grades, you will find pattern like if you were adding by 6, then 7, and 6 and 7, or when you were in kindergarten, like a pattern would be like heart, square, heart, square. So when there's a pattern, there's a way that you can expect or foretell what's coming next. So let's unlock the problem. We have a real world scenario here. Mr. Patrick wants to develop a new chili recipe for his restaurant. Each batch he makes uses a different amount of chili powder. The first batch uses 3.5 ounces. The second batch uses 4 5/6 ounces. The third uses 6 1/6 ounces. And the fourth uses 7.5 ounces. If this pattern continues, how much chili powder will he use in the sixth batch? So he uses different amounts, right, of powder. So remember that when we are reading a word problem, we want to highlight the information that it's important or underline. So I'm going to read this again because reading it once only is not enough. So it says, Mr. Patrick wants to develop a new chili recipe for his restaurant. Each batch he makes uses it's a different amount of chili powder. So we have the first batch. So first batch uses 3.5 ounces. The second batch, I'm going to use underline to underline the batch numbers. And then the second batch uses 4 5/6 ounces. Then we have the third batch that uses 6 6 ounces. And then we have the fourth batch that uses 7.5 ounces. So now if this pattern continues, this is a question that we want to answer. How much chili powder will he use in the sixth batch? Now this is key. We want to know the sixth batch. And he gave us up to fourth. So we need to find fifth and sixth. Sixth to find our answer. So we can find the pattern in a sequence by comparing one term with the next term. So when we're looking at patterns, we want to compare our terms to find the pattern. So here we have our steps. What we're going to do first is that we're going to write the terms in the sequence as equivalent fractions. So in order to compare fractions, like I've explained it before, if your denominators are different, it's like comparing apples with oranges. In order to be able to compare them, we need to have the same denominator. So that's the first step. That our sequence, we have to change it with the same denominator. Then examine the sequence and compare the consecutive terms to find the rule used to make the sequence of fractions. So there must be a rule in a pattern, a rule that tells us, okay, every time I'm adding so much or subtracting. So this is our batches. First batch 3.5, second batch 4 and 5 6, third batch 6 and 1 6, and the fourth batch 7 and 1/2. So now what we're going to do is we're going to rewrite them here using the same denominator. And to do this, we need to find the common denominator. Now, I could write like we've done before, though not necessary, but we could write our multiples of 2 and 6 to find which would be our common denominator. So if I write 2, 4, 6, I see that 6 would be my common denominator because, it's the least common one from both. So I'm going to use 6 as the common denominator. So for the first digit, 3.5, I would have to convert a half. Find the equivalent fraction. Oops, let me erase this because I was going to put a 6 instead of a half. So I'm going to have to find the equivalent fraction of 1/2 in sixth. So I know that the first, the numerator, I wouldn't know yet until I find out what number will I multiply the 2 by to get 6. And so 2 times 3 is 6. So that means that I'll multiply the numerator by 3. 1 times 3 is 3. So 3/6 is the same as a half. Now, some of you already know this because if you remember, with halves, basically, the denominator will be double the numerator. So 6 is double of the 3. That's another way to remember. So in this case, we're going to write our fraction would be 3 and 3/6. Oh, wait, let me write this with the math tool because it doesn't write it. 3 and 3/6. Uh-oh. I put tab and it took me to the end of the document. Okay, 3/6. Let me move this higher. So we have 3 and 3/6. Now the next digit is 4 and 5/6. Here we go again. I went to the end of the page. Okay, so we have 4 here and we need to put 5/6. And then the next digit is in 6, so we can keep it the same way as well. 6 and 1/6. And then 7.5, but we already know that a half is the same as 3/6. So I'm just going to rewrite 7 and 3/6. So if you can see here, we have all of our numbers using the same denominator so that we can be able to compare. Now we're going to find the difference. From 3 and 3/6 to 4 and 5/6, what is the difference? So what I can do is just subtract the biggest number by the smallest number. If I'm going from smaller to larger, that means I'm adding a fraction each time. But in order to figure this out, I'm going to subtract 4 and 5/6. Okay, again, where did I get this from? This is my second digit, okay? And it's bigger, so that's why I'm subtracting from that. And then I'm subtracting 3, which is the first term in my sequence, 3 and 3/6. Okay, so I'm going to subtract that to find out the difference between the terms. So basically, I go 5, 6 minus 3, 6 is 2, 6, right? So 2, 6. And then I'll subtract 4 minus 3 is 1. So if you see, I got 1 to 6, which they already gave it to me. And what we need to do is continue finding the difference. We keep doing that because it might be different. There might be a pattern where you're doing adding 1 into 6 and then adding 1, then adding. You never know. So you want to make sure by you know checking what is the difference to see if it's consistent. Okay, so we found the difference between the first term and the second term, or batch 1 and batch 2. So now we're going to subtract batch 3 from batch 2. And I'm subtracting from batch 3 because it's a bigger number than batch 2. If it was the other way, then I would subtract, I will switch the numbers. But in this case, it's increasing. So I'm going to find, you could use a scratch paper, you write it on the side. I'm going to go ahead and subtract. Why is it still holding that? Okay. I'm going to subtract 6 and 1/6 minus 4. I don't think that's a good idea to do it here, is it? Okay, let me move this up. Let's do it here. 6 and 1/6. And we're going to subtract 4 and 5/6. And see, on this one, we're going to apply what we learned last week, or the previous lesson, I should say, where we're going to have to rename. And the reason why we're going to have to rename is because 5 is bigger than 1. So we're going to have to regroup or rename the 6, make it into a 5, and add that whole to the fraction so that I'm adding 6 over 6. So now when I'm subtracting 7 over 6. Okay, so I'm going to subtract 7 6 minus 5 6. That is equal to 2 6. And 5 minus 4 is equal to 1. So if you can see in the pattern, it's still the same. So in the second term, I'm adding 1 and 2 6. Right? Okay, now we can do the same for the second one. I'm going to do this on this side. I have 7 and 3 6. And I'm going to subtract 6 and 1/6. So that's 6. And I'm subtracting 1/6. Okay, so when I do that, I have 3 6 minus 1/6. That is equal to 2 6. And then 7 minus 6 is equal to 1. So again, I got the same. So I'm adding each time 1 and 2 6. Okay, so here in my second step now, I'm going to write the rule that describes a pattern, and I need to find the other two batches, right? Because I want to know what is batch 6. So is the sequence increasing or decreasing? That's the first thing. I know the difference, but I need to determine whether it's increasing or decreasing. In this case, every time it's going up 1 and 2 6. So that means that the term is increasing, right? Because it's going up every time. So it's increasing each term, and the rule is each term increases by 1 and 2 6. So that is my explanation. The rule, or actually that's so the rule. I'm sorry. Or I could say here too that the previous term is it is smaller by 1 and 2 6. The rule is add 1 and 2/6 every time. So that's the rule. So now we're going to extend the sequence by adding the 2/6 to the next digit. So we know that our last batch, batch 4, was 7 and 3/6. So what we're going to do now, oops, is add 1, because that's a rule, and 2/6. And so that will give us 3 and 2 is 5/6, and 7 and 1 is 8. So that's our um, fifth batch, right? But that's not what the question is asking us for, right? It's asking us for batch number 6. So what we're going to do now is add another 1 and 2/6. So we're going to add 8 and 5/6. Add 1 and 2/6. So here we have 5 plus 2 is 7/6. And 8 plus 1. But before we keep going, notice that 7/6 is greater than, it's a fraction greater than 1. So I cannot leave it there. Okay, these needs to be regrouped. So I'm going to take away 1 whole. Remember that 1 whole is 6/6. So if I subtract from 7/6, I have 1/6 left, right? 1/6. So I'm going to cross this out and carry over the 1 whole. So now it's 1 and 1, 2, and 8, 10. So the sixth batch is actually 10 and 1/6. Okay, so remember, because when I added 5 and 2, that equal to 7. 7, the numerator is bigger than denominator. That means that this fraction is greater than 1. So 7/6, I need to rename it where I'm going to take away the whole number, which is 6/6, and that will leave me with 1/6, and I'm going to regroup that 1 whole with the whole numbers. All right. Okay, so here we have another example where we're finding the unknown terms in the sequence. We have been giving these numbers 1 and 3/4, 1 and 9/16, 1 and 3/8, 1 and 3/16. And now, if you don't know your multiplication facts, you might struggle. So you might want to put um, the multiples of the smallest number, which here is 4. Our numbers are 4. Let me write it with numbers. It's 4. Let me delete this one. Okay, our numbers are 4. And you probably can't see that. There you go. 4, 8, and 16. Now, I already know right off the bat that 16 will be my common denominator because I know that 16 is a multiple of both 4 and 8. But if you don't know, you could just write in 4, 8, 12, 16. And you can stop at 16 because I already see that that's common with one of my other uh, multiples, or the 16. And then we have 8 and 16. So our common denominator, now here on this one, notice that I had to find the common denominator from all of the terms. Like, because I need to have all of these fractions with the same denominator, then in this case, I will be listing all 3 numbers multiples, not 2, but all of the 3 different denominators. Very important thing to remember and keep in mind. So, because if we're writing equivalent fractions, we need to have a common denominator between all 3 different types of fractions. So now, after we have found what will be the common denominator, we need to write the equivalent fractions. And so we're going to write them here. So I know that the terms that already have a 16, those I will leave as is. But the ones that have, like, for example, the first one is 1 and 3/4. For this one, I'm going to have to find the equivalent fraction for 3/4. And we know that our denominator needs to be 16. So I'm writing 16 in my denominator. Now I need to figure out what is the numerator. So to get to 16, my denominator I needed to multiply by 4. 4 times 4 is 16. So now I'm going to multiply 3 times 4. 3 times 4 is 12. So my 12. So my numerator is 12. My fraction is 12 sixteenths. 1 and 12 sixteenths, right? So my first term, okay, would be 1 and 12 16. That's the equivalent fraction of 1 and 3/4. Now the problem with this is that it won't. Oh, I have an idea. So I'm gonna write 12. Oops, my bad. 12 sixteenths, and in the front we have the 3. Let me move this a little bit higher. Okay, that was my first term. 3 and 12 sixteenths. What? Not 3, 1. I was gonna say, and nobody corrects me. Oh, you guys can. You guys are not watching as I'm recording. All right, so it's 1 and 12 sixteenths, right? That was my equivalent fraction of 1 and 3/4. The next term, 1 and 9 12 and 9 16, sorry. 1 and 9 16 is already this one already has a denominator of 16. That means that I don't have to do anything to this. So here I'm just going to bring down or copy the denominator, which is 1 and 9 16. Okay, let me move this one a little bit higher. There you go. Okay, my next term is 1 and 3/8. So this one I do need to find the equivalent fraction. So in this case, I have the fraction is 3/8 with a whole number of 1. Okay, and so the equivalent fraction will be, well, we know that the denominator needs to be 16. So then I think 8 times what number will give me 16? 8 times 2, right? Okay. So now 3 times 2 is equal to 6. Make sure you bring the whole number. So the equivalent fraction of 1 and 3/8 is 1 and 6 sixteenths. So I'm going to write that here. 6 sixteenths. The whole number is 1. And let's move this up. Okay. Now, the next one is already has a 16 as a denominator. So I'm just going to copy it as is. 1 and 3 sixteenths. Bring it up a little. Now, the next 3 are the ones that I need to find. So we have a question mark there. And then the other one is 7 and 16. So just copy that one because it already has 16 as a denominator. And then finally, we have a 4th. So that means that we need to find the equivalent fraction of 1/4. In this case, I know that my denominator is 16. Oops. Now I need to think what number, 4 times what number equals 16? I know that 4 times 4 equals 16. So 1 times 4 is 4. So the equivalent fraction of 1/4 is 4 sixteenths. Okay, so I am totally ready, right? Well, I hope we are, to figure this out. Now, my next step is that we need to find the rule that shows the sequence. And so what I'm going to do is that I'm going to find the difference between term 1 and term 2. The way I do that is by subtracting. And what I want to do is subtract the biggest one by the smallest one. So which one's bigger, 12 16 or 9? Because both have a whole number. 1 is a whole number. But which one's bigger, 12 or 9? In this case, I see that 12 is bigger, right? So that means that I'm going to subtract 1 and 12 16 minus 1 and 9 16. Okay, so I'm going to subtract. And so 12 minus 9 is equal to 3. Remember, when you subtract fractions or add, you only subtract the numerator, not the denominator. 12 minus 9 is 3. And then the denominator is 16. And then 1 minus 1 is 0. So that means that 3/16 is what I had to, it is a difference from my first term and the second one. So I'm going to keep note of that. Now, here's where I need to think. Will I be adding or subtracting? From 12/16 to 9/16, did I go up or down? If I went up, I will be adding. If I'm going down, then I'm subtracting, right? So because I'm going down, in this case, I will be subtracting. So I'm going to write here, I'm going to write it in another color, and write it in red. Minus 3/16. Okay, so from term 1 to term 2, I went down 3/16. Now I'm going to do this again with the next term. I'm going to subtract 1 and 9/16 minus 3, 1 and 6/16. Now, if you can, this one we can actually do in our head, because remember, we're subtracting only the numerators. Denominators stay the same. And from what I can see here, okay, I just go 9/16 minus 6/16. So that's 9 minus 6 is 3/16, because 1 minus 1 is 0. So that means that I'm still following the same pattern. Minus 3/16. Let's move this up a little. I should have put it red. There you go. Okay, so we can continue checking, and I can actually check here. 7/16 minus 4/16. I'm just subtracting the numerator. 7 minus 4 is 3. So it's 3/16. So again, I'm doing minus 3/16. So it looks like my pattern is subtract 3/16. So I can now, with that information, I can find the 3 missing missing terms. And all I have to do is subtract 3/16. Look at this one, pretty simple, because it already has 3/16s, right? So if I subtract 3/16, if I subtract 3/16, like the pattern is going, then I know that my next term will be just the number 1. And then if I subtract again, now I'm going to subtract from 1. Now, when I subtract from 1, okay, remember when we're subtracting whole numbers, this is a whole numbers, and it can be written as 16 over 16, subtract 3/16, and that'll give me 16 minus 3, 13/16, right? So here, my next term is 13 over 16. Let's do this red. Let's move it up where you can see it. And so if I do it again, subtract 3/16, I can mentally say 13 minus 3 is 10. So my next term is 10 over 60. Now, these are not in simplest form. So it depends on what the question says. You can leave it like that, or you need to, or it might tell you to simplify. So it depends on what it says. So here we could just write the rule describing the pattern. What operation can be used to describe the sequence? Well, we're using subtracting, right? Because it's going down each time we are subtracting. So I'm going to use subtract. What operation can be used to describe the sequence well, actually, you know what? In this case, I want to use the word. I'm sorry. I misread the question. It says, what operation can be used to describe a sequence that increases? So if this sequence was going up, it would be subtraction, right? If the sequence was increasing every time, going bigger and bigger and bigger, that would be addition. If the operation is going down, see how the first number even had a whole number, but then at the last one, we have only a fraction. It's a smaller fraction. Well, that is decreasing. So when it's decreasing, we use subtraction. In this case, our rule is because it's decreasing, we're going to subtract each time not one, 3/16. And this didn't understand because I'm using the math teacher. So subtract 3/16. That was our rule. So we completed our sentence, the missing digits, and we found the rule. Excellent. So now you'll have a chance to try one problem, and then we will practice during our Zoom. Bye.